All right, everybody, this is 10.4. So, in our last lesson, we figured out how to find the vertex. The time before that, we learned about the growth pattern. So we're going to go back to 10.2, and we're going to revisit and see what happens if A is not 1. So all of the examples we've done, if we come up here, all these examples, we have A is 1. A meaning the leading coefficient. So here's an example where A is 1. Here A is -1. So all of these examples are when it's A is 1 or -1. So let's see what happens if A is not 1. Maybe it's 2 or 3. So to figure this out, let's start with the parent graph. That's y equals x squared. So we already did that in 10.2. We're going to do it again here. So if we were to evaluate, if we wanted to figure out this table, fill in this table, well, that's what we do is we substitute what x is, and we end up getting y. So we've got -3 squared. Again, that's just -3 times -3, which is 9. Okay, and then we can plug in -2. And if we plug in -2, we end up getting -2 times -2, or 4. And then we can continue this pattern, or this process, until we fill out the whole table. And just realize that every row of this table is an ordered pair. It's an x comma y, so we can plot that. So -3, 9, so that would be like right here. -2, 4. And this is where we kind of figured out the growth pattern is 1, 3, 5. All right? So we plot those points, we connect those dots. Okay, and we've got our parabola. It's not perfect, but that's pretty good. All right, and then we figured out that the pattern is that we always, from the vertex, we go over 1, and then we'll go up 1, and then we'll go over again, and then we'll go up 3, and then we'll go over again, and then we'll go up 5. And then that pattern keeps going. If we had a graph that's big enough, we could keep going. Okay? So that's when A is 1. Let's see what happens when A is 2. So here's an example where A is 2. And we're going to do the same sort of thing. We're going to fill in this table. So we already know what -3 squared is. So that's 9. But then we're going to multiply it by 2. So it's going to give us 18. And then we'll plug -2 in here. Well, we already know what -2 squared is. That's 4. But then we want to multiply it by 2. So we would get 8. And then if we plug -1 in, so that's -1 times -1. That's 1. And we'll times it by 2. So we get 2. And we plug 0 in, we'd get 0 squared, which is 0. And we'll multiply that by 2. And 0 times 2 is 0. So we're just evaluating these functions when x is these numbers. So we'd plug those in and we'd get those same numbers. Okay? You can use your calculator if you wanted to. So this was when we did 2 times -3 squared. Here we did 2 times -2 squared, 2 times -1 squared, 2 times 0 squared, and so forth. Okay? So if we were to graph that, at -3 it's 18, that's way out of our graph, but we could do -2, 8, and then -1, 2, 0, 0, 1, 2, and 2, 8. So we connect those dots. Okay, so just looking at these two, it looks like our second graph is more skinny, okay, and that's called vertically stretched. Okay, and if we look at the pattern for our first one, we went over 1, up 1, over 1, up 3, over 1, up 5. Okay, what are we doing here? Well, we're going over 1, up 2, over 1, up 6. So over 1, up 2, over 1, up 6. And if we were to go over again, well, here we can kind of figure that here. So it's like the difference here. So the difference here is 2, the difference here is 6. The difference here is 10. So it would go over 1, up 10. All right, so I want to look at these two, our growth patterns. the one when a is 1, so this is when a equals 1, and this is when a equals 2, what do you notice about the growth pattern? Hopefully you realize here that those values, when a is 2, the growth pattern is twice as big, which makes sense because we're doing the exact same thing. We're still doing x squared, but we're just multiplying everything by 2. It's doubling everything. So that doubles the growth pattern as well. All right? If we were to do this one, this is when a is 3. If we were to plug those in just to save some time, we'd get 27, 12, 3, 0, 3, 12, and 27. So here we can't graph it super well. I see 0, 0, and I see 1, 3 on both sides. But then the next one's out of their graph. Okay, but as you notice, it's more skinnier than it was when a is 2. It's being more stretched, okay, vertically stretched by a factor of 3. So the growth pattern, if here we doubled everything, what do you think we're going to do with the growth pattern here? Well, we're going to triple it. So instead of doing 1, 3, 5, we're going to multiply all of those by 3. And we'd get 3, 9, 15. So 3, 9, 15 would be our pattern. All right? So how does the a value impact the pattern of the parabola? Well, a just multiplies everything, or multiplies the scale factor by that a value, if that makes any sense. Well, I'll explain it a little better here, hopefully. So from the vertex, we have to always start from the vertex. We're always going to go over 1. And then from here, we're either going to go up or down 1 times whatever a is. So in our last lesson, or I guess when we'll finish this up, we'll go over 1, up or down 3 times a, and then we'll go over 1, and then up or down 5 times a. So for our last lesson, a was always 1, so we would just end up getting 1, 3, 5. But if a is 2, then we would double it. We multiply everything by 2, we'd get 2, 6, 10. Or if a is 3, we'd get 3 times 1 is 3, 3 times 3 is 9, and 3 times 5 is 15. So these are basically the ones, the growth patterns that you're going to use. Okay? And then still, if a is positive, the parabola is going to open up. So we're going to go over 1, up 1, over 1, up 3, or we'd go over 1, up 2, over 1, up 6, over 1, up 10, depending on what a is. And then if a is negative, then it's going to open down. All right, so this is basically the new part, is just being able to realize what do we do, what's our growth pattern when a is 2, or when it's 3, or if it's 1. We could do when a is 4, but most likely you wouldn't have enough points, because I always require that you're going to at least have 5 points, and if the growth pattern is getting too big too fast, then you might not see all the points. So let's do a couple of these together. I would love it if you could pause at some point and do the problem before I go over it. Make sure that you're understanding. All right, so the thing is that you're doing the exact same thing we did as last time. You're still going to need to find the vertex, and you do that the exact same way. So our vertex is an x and it's a y. Again, the x is always the axis of symmetry, which is negative b over 2a. Here, this is b. This is a. So we plug that in, we get negative 4. This is a lot of people are forgetting this. So please realize that the axis of symmetry is negative b. And if b is negative, then we're going to end up getting a positive. So negative 4 gives you 4. All over 2 times a, and here a is 2, so we'd get 4. And 4 over 4 is just 1. Okay, so now we've got the x for our vertex. So for our vertex, we've got 1 comma something. If you have an x and you need to find a y, we plug that back in to x for your equation. So we'll get 2 times 1 squared minus 4 times 1 plus 2. You can use your calculator, you can do it by hand. This one's not too bad. This is just 2 minus 4 plus 2. So here we get 0. I think I made a mistake. Hang on one sec. Let me double check this. Well, we will find out for sure. Actually, I think it's going to be okay. So we get 1 comma 0 is our vertex. Okay, that's what our vertex is. All right, so the vertex here is 1 comma 0. Is it opening up or down? Well, A is positive, so that's how we know. So up, it's opening up because A is positive. It's a positive 2. Growth pattern here, since A is 2, and we do 1A, 3A, 5A, so 1 times 2 is 2, 3 times 2 is 6, and 5 times 2 is 10. So that's our growth pattern. So we'll plot that. That's 1, 0. And then we're going to go up. So over 1, up 2, over 1, up 6, over 1, up 2, over 1, up 6 on both sides. And we'll connect the dots. And again, one thing we should always check, or at least very helpful, is to look at your problem and say, well, what should the y-intercept be? And again, the y-intercept is always the constant. So it should be 2, and here we have 2. So we know we got it right. Okay? So there's like a basic one. Here, let's try these other two. Pause if you'd like to, if you can. It'd be beneficial. So x is equal to negative b over 2a. Here, b is 8, so we're going to have negative 8 over, and we could put a parenthesis, over 2 times a. A is negative 2. So we'll get negative 8 over negative 4, which is just 2. And now we'll plug that in for x to find our y. So negative 2 times 2 squared plus 8 times 2 minus 6. Again, we can use our calculators if you'd like, but I think we end up getting 2. Okay. Yes, I think that'll be good. So our vertex here, I guess we'll write it here, will be 2 comma 2. And the direction of opening for this one, A is a negative 2, so it's going to go down because A is negative. Pattern here again is the same. We're going to go down 2, down 6, down 10. So we'll go to 2, 2, over 1, down 2, over 1, down 6, both sides. Connect our dots. Looks good. We can verify our y-intercept here is negative 6, and the y-intercept that you graphed is negative 6. All right, last but not least is a equals 3. So same thing, vertex is an x and a y. It's x is negative b over 2a. Here b is 6, so negative 6 over 2 times a, and here a is 3. So we get negative 6 over 6, or negative 1. We'll plug that in. So we get 3 times negative 1 squared plus 6 times negative 1 minus 1. And we could put it into our calculator, but this one's not too bad. I think we'd get 3. So remember, we would square that first. So negative 1 times negative 1 is 1, and 1 times 3 is 3, minus 6 minus 1. So I think here we end up getting, what, negative 4? Okay, so that's our vertex, -1, -4. For this one, it looks like A is positive, so it's going to open up. And our pattern here, again, it's 1 times A, 3 times A, 5 times A. Since A is 3, we'll do 1 times 3 is 3, 3 times 3 is 9, and 5 times 3 is 15. Okay, but usually we won't be able to fit that 15 in your graph because that's pretty big. So anyways, we're starting at -1, -4. We're going to go over 1, up 3, over 1, up 9 on both sides. So again, this is really stretched and skinny. It's vertically stretched by a factor of 3. And there you go. So that's what we covered today on your homework. I think a couple of them I'm going to ask you to find the key features that we did in 10.1, and then a couple of factoring problems just to keep you reviewed with that so we can use that in the future. If you have any questions, please let me know or stop by. I'd love to see you. See ya.